Hi folks, welcome back to the fourth video in 10.3 hyperbolas. So here we're going to take a look at how we can write equations for hyperbolas, specifically ones that have a center at the origin. So let's go ahead and get started with number 9. So the vertices are given and the foci are given. Now, I know that these vertices are in the vertical direction, which means that my y squared term will come first. And I know that this foci coordinate, the 0, plus or minus 4, is going to help me find my b value, or my b squared. So use this to find b squared. Okay, I'm going to go ahead and set this up y squared over something minus x squared over something equals 1. Because I know at the end of the day that's going to be the structure of my answer. Now, the number underneath y is going to be a 1 squared. Because I'm going up and down 1. Now let's use the foci to help us find our b squared. So c squared equals a squared plus b squared. And that's going to give me 4 squared equals 1 squared plus b squared, which is going to give me a b squared of 15. And so I can put a 15 right underneath here. Okay? So pretty straightforward in terms of being able to find the different pieces of information, but really important that you know which letters correspond to which parts. All right, let's move on to number 10. I have vertices and foci again. That's supposed to be a comma. Now, I know that this one is going side to side first, so that means my x squared comes first. And I can use this to find my b squared, or the number under y squared. So let me set up my structure, x squared over something minus y squared over something equals 1. All right, now I know that the number under x squared is going to be 3, and I know I need to square it. So I could write 3 squared, or I could write 9. And to use the foci to find my b squared, I'm going to plug everything into this equation. 25 equals 9 plus b squared, or b squared equals 16, and that's the number I can put under number 10. All right, let's go ahead and move on to example number 11. All right, so this time I have my vertices in the x direction again, so x squared is going to come first. And then they've given me my asymptote equations, so it might be actually helpful to kind of draw a graph here. All right, so I'm going to set up my structure, x squared over 3 squared minus y squared over, I got to find that b squared equals 1. And off to the side, let's draw a quick picture. So, what do we have? Well, we have our vertices at -3 and +3. And I know that to find my co-vertices, I'm going to have to go up 2 and over 1. So that's going to get me all the way to a point in the corner over here that has a slope of 2. So if this x coordinate is 6, then the y coordinate will be 3. And all of that helps me determine the box for the structure of the hyperbola. Now, I know that I go up 6, and so that actually gives me my b squared, so 6 squared, okay? So 2 is a reduced form of b over a, and so we just want to sort of unreduce it to get it to fit the points that we have. Okay, let's take a look at two more questions. The foci are 0, plus or minus 10. And the asymptotes are y equals plus or minus 1/3. So because these are in the y direction, I know y squared is going to come first in my equation. So y squared over something minus x squared over something equals 1. And it's my job to fill in those bottom two numbers. So I'm going to use a graph again to help me with this one, because I find that with the asymptotes, it's actually nicer to have a picture. So I know that these asymptotes are going to go over 1, or up 1 over 3, up 1 over 3. So at the corner edges of my box, all right, I can actually represent this coordinate as 3y over y, or comma y. And that is because I have a rise that is smaller than the run. So I'm going to use this in the c squared equals a squared plus b squared equation to help me figure out some other numbers. So I know my c is 10, so c squared is going to be 100. And then I'm just going to plug in my a squared, or 3y squared plus y squared. So I'm going to use this as my a and this is my b. And I'm going to distribute, and so I'm going to get 9y squared plus y squared. That gives me 10y squared, and that makes y squared equal to 10. So I know the number under y squared is going to be 10. Now, once I have y squared, I have to find the number under x squared. And that is just going to be my b squared. So I need 3 times, so I need that to be 100 equals 10 plus b squared. And that means that 90 equals my b squared. So I have a 90 underneath that x squared. All right, let's take a look at one last example here. Okay, so we have y-intercepts at 0 plus or minus 2. That means that the y squared comes first. And we know that we have asymptotes of this. So this is going to be similar to what we had last time, except we actually have a little bit more information. So I'm going to draw a picture. And I'm going to go ahead and outline where my vertices are. So I have them at +2 and -2. And the question then is just sort of like, how long is this box? Okay. Now let's think about this coordinate. If I have a slope of 1 over 4 and I start at the center, I'll go up 1 over 4 and then up 1 over 4. So that would give me a point of 2, 8. No, that would give me a coordinate of 8, 2. My goodness, 8, 2. Now what's important about stopping here is this 2 is the same as this 2. And so I know that I can stop there instead of having to keep going because my y-intercept is at plus and minus 2. All right, so what does that tell me? Well, that tells me I have y squared over 2 squared minus x squared over something equals 1. And I'm going to use the Pythagorean theorem to help me figure out how far I've gone out, all right? So I have Actually, I'm not going to use the Pythagorean theorem, sorry. I'm just going to count because this tells me how far I went side to side. That's my 8, so I have 8 squared. And again, you could certainly write this as y squared over 4 minus x squared over 64 equals 1, and that would also be acceptable. All right, folks, we're going to stop here for 10.3. As you can tell, my brain is getting a little tired, but the full solutions will be posted on Canvas, so make sure to check those out and have a great day.